Hello and welcome to episode 3, The Big Bang Part 2. For those that did not see episode 2 yet or have no idea what the Big Bang is, it's the prevailing theory that attempts to explain the origins of our universe. The Big Bang is not the only theory in town. There's, for example, the Big Bounce and there's the Big Crunch. And you get the theme here that it must have been big for them to continue using the word big all the time. And I assume they'll continue using it as more theories come out. Maybe they'll come up with the Big Kahuna or the Big Lebowski or some colorful name that certainly will get your attention. But you get the idea. The creation of the universe was a big deal. Now, in this episode, I'm going to focus in on what happened after the Big Bang. Episode 2 dealt with basically the fundamentals of the Big Bang: singularity, inflation, black holes, fuzzballs, and a number of other things. So you can see that transition as we go from 2 to 3. So let's get into what actually happened. What are the artifacts? What's the sequencing of our universe? Let's start off with what happened 13.8 billion years ago till now. I don't know about you, but it's hard to imagine we came from basically everything in the nothing state to where we are today. And you think about, well, what actually had to happen in order for that to occur? And it's a head scratcher as to what was created from this event. And let me give you some numbers as a reference point. If you look at our galaxy alone, the Milky Way, there are upwards of 400 billion stars in our galaxy. Now, I'll repeat that again. 400 billion stars in our galaxy. Now, that's a number that, I don't know about you, but it's really hard to fathom how many stars that is, because that doesn't even include the planets around these stars and the dwarf planets and moons and asteroids and everything else that goes along with it. So start off 400 billion stars in our galaxy, and the current estimate in terms of the number of galaxies in our universe is 2 trillion. So let's see what we got here. 2 trillion times 400 billion, and that's only the stars, equals insanity. It is so large. I don't know about you, but my pea brain can't even I can't get my head around it. It's so large. And it's one of those that I sort of get it, that again, I just can't imagine that there's that much up in space in what constitutes and comprises our universe. Anyhow, closer to home, let's talk about not only just quantity of what's out there, but how fast things are moving every second of every day. For example, the Earth is rotating over 1,000 miles an hour. So every time it rotates in 24 hours, it's at that speed, we're going at 1,000 miles an hour. On top of that, we're orbiting the sun. So we're spinning and we're doing one of these numbers, around for, over 365 days for a year. The speed at which we're going around the sun is 67,000 miles an hour. Okay? Now that's 87 times the speed of sound. So there you have it. So you have the sun, you have the Earth, and the other planets. We have Saturn and Jupiter, etc. And they're all doing the same thing. They're spinning and they're orbiting the sun also, and we're all sort of in different phases. So that thing is going on. Then on top of that, our solar system, that being the sun and the planets, it's moving within our galaxy too. And the speed at which that's occurring is around 500,000 miles an hour. So, okay, so spinning around the sun, then our solar system, it's moving around the galaxy. And then on top of that, the galaxy is moving in the universe at 1.6 million miles per hour. So we're doing this. It's crazy what's going on. And this is happening throughout the whole universe. Things are rotating and revolving and orbiting and moving, and it's just this endless, constant moving. It's mind-boggling. But anyway, let me bring it a little bit closer to home. What's weird about all of this happening is we can't sense that we're moving at all. None of this. I'm sitting here right now and I can't feel anything. We never can feel it. But what I can say is, just so sort of if you want to use this at a party one time, if instead of 24 hours in which our Earth rotates one time, it was 84 minutes, you'd start seeing people fly off, at a minimum, the equator. They'd be flying off the Earth, along with oceans and all types of things that would basically tear our planet apart. So, not that I want to see that or anything, but I thought, how fast would we have to go to really have some fun around here? And that would be the 84 minutes in one rotation. All right, so from there, let's get into the artifacts and the timing. So I'm going to describe this in context of, here's the context for it. I'm the universe, and the universe hasn't been created yet. I'm sitting in the singularity, and I'm thinking to myself, what do I want the design of my universe, of me, to be? And I'm going to describe it from that perspective, all right? So here we go. Now, by the way, everything that I'm going to be mentioning in this particular section, I'm going to be discussing in future episodes because there's just too much to explain right here. So you just have to bear with me and remember some of these terms, and then we'll dive into each one of them a little bit more in the future. So here I am, I'm the universe, and I'm thinking about, all right, what do I want my design to be like? So we'll start off with, okay, I put myself into the singularity, in a black hole, or maybe we could put it in a fuzzball. But anyway, it doesn't matter. Either one's fine. And then one day, I'm going to basically propel out of this black hole or fuzzball or whatever it is. I'm going to go into space. Everything in the universe is going to just go Big Bang. Okay, so I like that. So we're going to get in there, everything in the nothing area, and then we're going to expand outward. Now what I need to do is, because there's no space at all, because everything is in the black hole, there's nothing. I'm the universe. If everything in the universe is in the black hole and the singularity, there's nothing outside. So I got to create space first. I got to have some space. I got to move in it, and the things that I create need a place to live. So I'm going to create space. But not only that, I need to create time. And on top of that, I'm going to combine those two, and I'm going to call it space-time. Okay, I like that. That's a concept that's really difficult to understand, and I like difficult things. Then the next thing I'm going to do is I need forces to stabilize this environment overall. And I think I'm going to come up with, 4 forces would be good. One is gravity. Another one would be electromagnetism. Another one would be the strong nuclear force. And then the fourth would be the weak nuclear force. Now, that's good. Those 4 will cover quite a bit, I think, in terms of what I want to do. Now, those forces, they need something to basically they need to force upon something, and I need to create these things. So what I have to do is create fundamental particles. And I'm thinking about, there's 3 in mind to start off with. I think I want to create some electrons. Now, these are charged particles, and don't ask me what a charged particle is, okay? I'll tell you that later. That's at a different time. Then I'm going to create photons. When you think of photons, you think of light, because we need light, because it could get dark if we don't have light. And then neutrinos. Now, I like neutrinos. It reminds me of like a city in Italy. So we're sticking with that one for sure. Neutrino is in. So I got my 3. Got that handled. Now, what I need to do is on top of that, I need heat. You can't do anything without heat. So I'm going to create plasma. Now, plasma, I'm going to create things in solid, liquid, and gas state. But I also need a plasma state. In plasma, it's an ionized gas state. And that will be good because we need plasma because it's hot. And when there's hot things happen. And as a matter of fact, this plasma, I'm going to make it up out of things called quarks and gluons. Now, quarks, that name I like because it's quirky. And gluons, as you can imagine, the word glue, that gives you a clue. We always need glue. So that will be very important in our universe too. And then last, I'm going to create these fundamental particles like electrons and stuff, but I want to create subatomic particles too. So a subatomic particle is made up of fundamental particles. So you combine them and you get these subatomic particles. And the two that I'm thinking about are protons and neutrons. And I'm thinking a little bit down the road here that I want to create basically something called an atom. In this atom, I'm going to have protons, neutrons, and electrons in them. I like this. So basically, I have the foundation of the forces. I have particles to make stuff with. I have plasma to heat stuff up with. So I'm liking what's happening here. Okay, now what I'm going to do next is I'm going to get these protons and neutrons, and I really want to fuse them together, because what I want to do is to build things. It's sort of like Lego blocks that you want to join things together as a part of building the universe. So in doing that, what I'm going to do is I'm going to come up with a process to fuse protons and neutrons together. And the reason why I want to do that is I want to create these things called elements, light elements, hydrogen and helium in particular, because those two, I'm thinking about, they can be the foundation of stars and to create heat, because we need heat, different type of heat than plasma. This is heat that we need as a part of, as the universe evolves into what I want it to be. And I'm thinking about a word that I can use to describe the fusing of protons and neutrons, and I've come up with one. It's one that's hard to say because there's S in it and a TH in it. So what I'm going to do is I'm going to pronounce it slowly so you get it. And it is here it comes. It's nucleosynthesis. There you go. I like that word. It sounds important, and it is important. All right. Now, I'm going to wait, maybe a couple 100,000 years just to let things settle down. And what I want to do is, at that time, I'm going to cool down this universe, because what I want to ultimately do is I want to merge the electrons with the protons and neutrons to make these things called atoms as the building block to build and make other things with them. But electrons, they like it, the heat. It's not a good environment for them. So I want to cool things down and then merge these things together, fuse them together to create atoms. On top of that, because it's hot, as we get these electrons and protons and neutrons together, then it opens up, it's dark. It's been dark up to this point. And when I do that, light is emitted, and now we can see what's going on. So basically, I've been operating in the dark in a lot of ways, even though there was a lot of energy created as a result of the Big Bang. But the bottom line is, I need some light, and this is how I'm going to get it. Now that I have light, and I'm creating these atoms of hydrogen and helium, I can now create stars and galaxies now. Now, this is going to have to happen hundreds of millions of years after the Big Bang, because things need to sort of play out here. And now what I can do is I can create stars with the hydrogen and helium. Now I have gravity too. So I have these combination of things that now I can start creating stars. And stars, using hydrogen and helium, it will generate heat. And when you start generating heat, that sort of gets things in motion. And then sometimes stars, they explode. And that's what we're going to do. And when the stars explode, after so many years in the universe, what happens is they're going to explode, but they're going to release heavier elements beyond hydrogen and helium. They're going to explode out and expand in the universe elements like carbon or gold. And then they'll go into space and they'll be consumed and merge with other things. And then I'm going to create other solar systems where I have these stars, and then a matter that is floating in space will get caught up into the gravity of these stars, and it's warm, and things start spinning around, and you create these solar systems. It's genius. I love the idea. So anyway, you get the point. It's continuing, this process is continuing to this day as to the universe evolving and forming new things and stars exploding, and they're called supernovas. And it's just a very dynamic thing. So you just sort of get the feel for what was happening from the beginning to where we are right now. I mean, I can go on and on, but I'm not going to go down that path anymore. A few observations of just what I went over. One is, at times it appears like the sequencing of the universe's creation was almost like preordained. It was almost genetically, it's inherent in the universe itself. It has knowledge of what to do. On the other hand, the universe can be very random. And so, you can take two different views of how it all came about. And there's a part of me that sort of lands somewhere in between the two. So that's number one. The second item is the things that were created from the Big Bang are really strange. In other words, who would ever think of an electron, or who would think of gravity? I mean, it's just a weird concept. And when you have some time, if you had a blank piece of paper and you had to form your own universe, what would you do? What would it look like? Would it look like what we have today, or would you do something differently? It's just an interesting discussion. Third, everything in the universe it's a well-oiled machine. In other words, everything is integrated together. There's no solo performers. It's all for one for all type of environment. And the more you know about the universe, you come to realize that everything is truly interconnected. And you might not be aware of it, but we are connected with everything and one another like you have no idea. The fourth thing that comes to mind is, how is it that everything I just talked about, essentially, you can't see? In other words, when was the last time you saw an electron or a proton or a neutron? Your body you're composed of all of them, a gazillion of them, but you really can't see it. You won't be able to see one for your entire life. So how could it be that there's all this invisible stuff in the universe? We can't see it, but it's controlling us and interacting with us every day. That's a real head scratcher too. And the last one being, if you look back at what I just described, the question is, how credible is that, and how accurate is that in terms of the sequencing of what I just described? And based on experimentation and observations and a number of mathematical models that have been run, thermodynamic models, etc., the sequencing follows a given pattern in terms of how things come about. So generally speaking, the sequence in which I described, it might not be dead on accurate, but it gives you a general idea of how the sequencing probably likely occurred. So, with that said, that's where we are. We went from a big bang to where we are today, and we got there from point A to B based on what I just described. Now, in closing, what I'll say is, I've mentioned we're in the Big Bang series, but the name itself is a bit of a misnomer, in that it really wasn't violent, and it was silent, actually. And that's what episode 4 is about, explaining how it could be both violent and silent at the same time. And you'll find that out in the next episode, and I'll talk to you then. Bye-bye.